Hi, good morning. So today we're going to be looking at the lesson for pre-calculus for chapter 1.5, which is titled Inverse Functions. Make sure you write your first and your last name and what period you're in. And here we go. So today for inverse functions, the main point that you need to know about inverse functions is that they undo each other. And so either yes, that's going to happen, or no, it's not going to happen. So yes, they are inverses, or no, they're not. All right, so the first thing, or the main question you're going to be asked is, are the functions f and g inverses of each other? We have f is 4x minus 9, and g of x is 1/4 x plus 9. So generally just look at them like, are the same numbers involved? Are opposite operations happening? And so sometimes you can kind of say, yeah, they basically look like they're going to be, or no, they completely don't look like they're even going to be, and sort of make a judgment right away, like subtracting here, adding here, multiplying here, dividing here. Okay, so there are inverse operations. So let's see if it's true. And so the way to do it is if you get x each time, then you'll say yes. If you don't get x, then you'll say no. All right, so for every x in the domain of g and for every x in the domain of f, if the functions are inverses of each other, then they can be renamed with this little symbol that looks like a negative exponent. So that's called the inverse. The g of x is the inverse of f of x, or f of x is the inverse of g of x. All right, so here's what it looks like. You're going to take the g and plug it into the f. So that's the 1/4 times the x plus 9. We're going to plug that into x on the f function. So 4, here's all the x stuff, minus 9. And it looks a little bit complicated, but because they should be inverses of each other, they should undo each other, right? So the 4's cancel, and we have 1 times x plus 9, which is just x plus 9, minus the 9. And then these two are opposites, so we're just left with x. So far, so good. All right, now let's try it the other direction and see if the same thing is true. So this time, we're going to take the function of x, which is the 4x minus 9. We're going to plug it in here where the x is at, so we're going to have 1/4 times the 4x minus 9 plus 9. And again, it looks complicated, but because they should undo each other, it should work out fairly easily, right? So within the parentheses, if we follow order of operations, these guys are opposites, right? So you don't even need to write plus 0. We're just left with that 4x. And 1/4 of 4x is just x. And so we got x here, and we got x here. We're good to go. We say yes, they are inverses of each other. All right, moving on to the next slide. All right, so state if the given functions are inverses, and we've got a different f of x and a different g of x. And I'm seeing some 3's, I'm seeing divisions. Maybe they're inverses of each other. Let's see, okay? So we're going to start with all this stuff for g and plug it into this equation where this x is at. So where the x was at, we plug in 1 over the negative x plus 3 plus 1. And let's see, these are opposites, so they cancel. And we're left with negative 1 over 1 times, negative 1 over 1 over x, negative x plus 3. And then over here, that simplifies to the negative 1. And we're going to switch this from, we're going to divide by a fraction. So dividing by a fraction, we're going to switch it to multiplying by the reciprocal. So I'm going to flip this denominator, move the 1 down to the denominator over here, and move the negative x plus 3 up to the numerator. This gets a little confusing, but we've got negative x times, negative 1 times negative x which is positive x. We've got negative 1 times positive 3, which is negative 3. And then we have this plus 3 over here. These two are opposites. They go to 0. And we're left with x. Okay? All right, so that one simplified to x. Let's see if the inverse simplifies to x. So this time we're going to take all this stuff for x. We're going to plug it in right here into the g of x where this x is at. So where this x is at, we need to put the negative sign out in front of the parentheses. There's also a plus 3 in that denominator. And then after that fraction, we're going to add the 1 over here. Okay, so first distribute that negative sign. That makes that positive. That makes that plus 3 minus 3. And then these guys are opposite and they go to 0. So now we have another fraction divided by a fraction. So we're going to multiply by the reciprocal like we did over here. And that gets us the x minus 1 in the numerator, the 1 in the denominator. The 1's cancel, and we're just left with the x minus 1, plus this 1 over here. And then these guys are opposites, so they go to 0, and we're left with just x. So we have x, and we have x, so we say yes, they are inverses. All right. Pay attention to your signs, pay attention to the order of operations on these, okay? Because one little mix-up can mess you up, all right? All right, so on the next slide, we're going to state if the given functions are inverses, and we have a new function of x, which is negative 3x minus 5, and a new g of x, which is negative x plus 3 over 6. So we're going to start with the g and plug that into the f where that x is at. So we have this negative 3 written right here. Where the x is at, we write all of this stuff for g, the negative x plus 3 over 6 minus the 5. All right, I'm going to reduce the 3 and the 6. 3 reduces to 1, 6 reduces to 2, and then I'm going to take that negative sign and distribute it here and here. So negative times negative x is positive x. Negative times positive 3 is negative 3. And rewrite that 2 in the denominator, minus 5. Okay, I'm going to separate this to two fractions, x over 2 minus 3 over 2. And then I'm going to write this negative 5 with the same denominator of 2. And 2 goes into 10 5 times. So I just doubled the 5. So now I have a common denominator, and I end up with something like x minus 13, which is not equal to x. So these are not going to be inverses of each other, which was our guess right at the beginning because we don't have the same numbers and opposite operations of each other. Okay? All right, the next slide. Two new functions. F of x is 2x to the third. G of x is the cube root of x plus 1 over 2. And just at a first glance, we have a cube and a cube root. Those are opposites. We have multiplying by 2 and dividing by 2. Those are opposites. We have subtracting 1 and adding 1. And those are opposites. So if you had to make a guess up front, you would say, yeah, they're probably going to work. So let's try it. We're going to take the g, all of this stuff, and plug it into this equation, or into this expression where the x is at. So I wrote 2 times all the x stuff to the third power minus 1. And this looks tricky, but the cube root and cubing are inverse operations of each other, so they actually cancel each other out, and we're just left with x plus 1 over 2. The 2's cancel right here, and we're just left with the x plus 1 and the minus 1 afterward. These are opposites, and they go to 0, so we're just left with x. Okay? Let's try the inverse and see if it's true. Okay, so now we're going to take this 2x cubed minus 1. We're going to plug it in right here for this x. And so we're going to say the cube root of the 2x cubed minus 1 plus 1 all over 2. The minus 1 and the plus 1 are opposites, and they go to 0, leaving us with 2x cubed. And then the 2's cancel, so we're left with the x cubed. And then cubing and cube rooting are inverse operations, so they cancel each other out, and we're just left with the x that's inside. So we ended up with x here, and we ended up with x here, so we say yes, they are inverses of each other. All right, so let's practice finding the inverse. And there's a little trick. So the first thing you want to do is you want to take the function of x equals 2x minus 5 and just rewrite it as a function of y. So function of x is just fancy notation for y equals. Think about when you're graphing. Y equals 2x minus 5. It's just a line, right? If you can type it into Desmos as either y equals 2x minus 5, or you can type it in as the function of x equals 2x minus 5, and it reads it either way. They basically mean the same thing for each other. Okay, so first just rewrite it with y. The second step is you're going to switch the x and the y. So right here where there's an x, you're going to write a y. Right here where there's a y, you're going to write an x. Okay, then you're going to do your Algebra 1 skills, and you're going to solve for y using inverse operations to get the y by itself. Okay, so the first thing you want to do is add 5 to both sides, so that 5 moves over here. And then you have the 2y by itself, so you divide everything by 2. This gets divided by 2 and you end up with y. This gets divided by 2 and you end up with x plus 5 over 2. So the inverse of the function, and you write it with this fancy notation of the inverse function of f, is equal to x plus 5 over 2. And that's always the last step, is to use their fancy notation. Okay? Let's try it with another function and see if it gets in a little bit easier. So we're going to take the g of x and change it to y. Then we're going to switch our x and y variables. So here's the x, it gets switched to y. Here's the y, it gets switched to x. Okay? The next thing we're going to do is inverse operations. So to undo this square root, we actually square both sides. And the squaring and the square root cancel each other. That leaves us with the inside expression, which is 2y minus 3. And now we have x squared over here. The inverse operation of subtracting 3 is adding 3, so I added 3 over here. And then the inverse operation of multiplying by 2 is dividing by 2. So we end up with y equals x squared plus 3 over 2. And then the very last step is just to use this fancy notation. So change the y to inverse of the g of x. Okay. All right. So for C, let's find the inverse. So the first thing we're going to do is change the notation for h of x to y. Rewrite the rest of it. Then we're going to switch our x and our y. So here's our x, it goes to y. Here's our y, it goes to x. Then we're going to undo all of our operations. So to undo dividing by 2, we're going to multiply both sides by 2. So the 2 comes over here and it cancels over here. Then we're going to subtract this 5. So we got minus 5 over here. Then the inverse operation of cube rooting is cubing. And then those two cancel each other out, leaving us with the 6y inside. And the inverse operation of multiplying by 6 is dividing by 6. And then the last step is to do the fancy notation. This says that the inverse of h of x is equal to 2x minus 5 cubed, all divided by 6. All right, D looks a little bit easier. So we're going to change the h of x to y. And then the second step is to switch our variables. Here's our x, change it to y. Here's our y, change it to x. And then do inverse operations. All right. First thing we want to do is the inverse operation of multiplying by -2, which is dividing by -2. And you can either put that negative sign here or here. It technically doesn't matter. And then the inverse operation of the 5th power is the 5th root. So we're going to take the 5th root of both sides. So the answer looks like this, except for you need the fancy notation. So you change the y to the inverse of h of x equals the 5th root